When you're building applications, you'll frequently pick up that you're reusing certain components quite often. When you have to copy the components and duplicate them for this use, you'll find that your dashboards get extremely big and unmanageable. To solve this problem, we have traits in Opus. The problem that traits solve is that it allows us to reuse components and reconfigure components in certain ways through config properties to make your application more manageable. So to illustrate this point, I'm going to build a simple inputs component. So in my dashboard, I'll have a container, give it some padding, background color, and inside I'll have an icon and an input. Just fix our margins and make the padding a bit smaller. Change the icon to lock. Okay, so here we have an input component that we'd like to reuse. So you might this up over there. Change the first one. And just give this one a margin top. Right, so there we have our component that's being reused. Now to illustrate the points of traits, I'm going to make a folder in here. We'll discuss naming conventions and folder strategies for traits as well. But for now, I'll just make a folder called traits. I'll copy the components I want to reuse and just make a file here, call it fancy input. Literally paste the entire component and add an additional keyword except PRPS, except properties. Just make an empty object for now. Now what we can do is we can replace this whole component with the trait. So it looks like this. We have a traits array. We're specifying which traits we want to implement for this component. This is the path to the trait and trait properties, which we will discuss right now. So the path to the trait, very often you'll be able to use relative pathing. So relative to the folder where I am now, I'm inside this folder. So to kick off relative pathing, I do // I want to go inside the traits folder to the fancy input trait. Deleting this one as well, replacing it with a trait implementation. We see both being rendered. Now we need to deal with the fact that we want to customize the icon and the placeholder text, for which we use trait properties. So trait properties, first we need to specify the properties up here inside accept props. The first one will be icon. We can give these any names we want. And you can specify just this, it's a string. I can also do a placeholder, it's a string. It's advisable not to do this, but instead to do it more complete, I specify that icon, then our object, specify the type. This is a string. It could also be number or boolean. It could also be an object or an array. But it's important to note that this doesn't actually mean anything to Opus. Opus doesn't do anything with this at the moment, although in the future we will use this for data type checks. But this is more for people using the trait to understand what they need to pass in. So type is a string and placeholder as well. is a string. We're going to do more with this object later, but for now it's just important to know that you have to specify what you'll be passing in and what the data type is. Now we can use these when we need them. So over there, now we do percentage icon, that's the name of the property, percentage. Over here, percentage placeholder, percentage. Now by default, obviously nothing's being passed into these, so we won't see them. So we need to specify what these values will be. So now we can specify trait props, icon, and placeholder for the second one as well. Now we have two traits. This is called implementing a trait. I'm implementing a trait for this component, and I've passed properties into this trait. Another thing we can do with trait properties is override Boolean values, of course. So we could, for example, disable an input. We could say enabled. Let's just make it enabled false by default. So all of them will be enabled false. Now I can't click in these because they're not enabled, but I can override this type Boolean. And now when I use it, I can't use percentage because this will inject the string value. I'll demonstrate this. Let's make this one enabled false and the first one enabled true. So both are enabled at the moment. To understand why, we'll inspect our DevTools, look at the input itself, and inside the state you'll see that the enabled property is true, but it's a string. It's not a Boolean value. To counteract that, we have to use dollars instead of percentages. So now we're going dollar enabled dollar. This injects the true value. Refreshing now. First one is enabled, second one is not. We can also specify default values for traits by doing dft inside this object. True. Now I can remove this one because it'll just use the default value. It's enabled and not enabled. There's more we can do with traits, but to properly illustrate that I want to draw it out first. When you think of traits and how they function on components, you always need to imagine this in your head. So what we'll do is we'll illustrate. That's a bit too thick. We have our curly brace. On the left hand side we have a component, on the right hand side we have our traits. If we have a key in here and the same key in the trait, and if we have maybe an object in here as well for properties, just imagine this is an object, object. We have a key in there and the same key on the right hand side. When you apply the trait, let's see what happens now for this. So inside our components over here, we have our traits. Now remember this is still a component being used. This is still a component because everything on the right hand side, like the type we specified and the properties we specified inside the trait, just get injected on the right from the right hand side into the left hand side. They're overriding this component, but this is still a component. This component just becomes whatever the trait tells it to be, but we can still specify properties for it. So let's go and specify something that we already have. So for the container, because remember this thing, the trait, is injected into this one. So we know we have a container simple, and we know we have direction horizontal. So we specify direction vertical. Now you'll see that this is being used instead of the trait value, meaning that anything you specify in your component will take authority over what the trait specifies. So even though the trait does specify direction, we can override it over here there's one edge case that you need to know of, and that's IDs. If you specify an ID inside your components over here, inside your traits over here, my trait input, I haven't specified an ID over there, just in the traits I have the ID. You'll notice if you refresh this, you won't find that ID anywhere. So the container, which should have received my trait input, has received a random ID. This is because Opus, when it generates the component and applies traits, before it applies traits, it generates a random ID for components if they don't have IDs already. So even though we know there is an ID inside the trait, it won't be applied. To get around this, we can specify in the trait, we can specify auth. That's an array of strings. We're telling it which keys should be authoritative. So in this case, we're telling it that the trait is in charge of assigning an ID to us. So now if we refresh, look at our component, you'll see the ID is being applied properly. We can also do the same for our properties. For example, if we specify a background color over here, which we know will take precedence, here we can see the red background color, even though the trait has light gray. As expected, this one has overridden that, but we can also specify, I'm doing this wrong, it has to be like this. So I can specify that the background color value inside my PRPS array takes precedence. So now even though we have specified a new background color in our component, the trait will override it because we've told it to do this. So let's just fix this up again. Remove the ID. Next, we can discuss flows and scripts for traits. There are certain values inside your component that will be overridden in a different way. So we've seen that values that are the same, well, not values that are the same, keys that are the same, the trait will inject them only if they don't exist on the left-hand side. So if we do have a background color specified in props, this will not be injected there. If we already have a type, for example, specified over here, it will not be injected unless we specify in our trait which properties are, or which keys are authoritative.